Okay, so let's say we have this question here where you have two angles A and B. They are both in between 90 degrees and 270 degrees. Also, you're given that tangent of A is positive 8 over 15 and tangent of B is negative 24 over 7. Part 1 asks you to find cosine of A minus B. Part 2 asks you to find secant of A minus B. So the purpose of giving you this information at the beginning is to tell you to do the following. The first step, find out the quadrant that angle A and B belongs to. Okay, so basically use ASTC. So let's figure this out. 90 degrees to 270 degrees. Now, 90 degrees to 270 degrees means you rotate from the positive x-axis 90 degrees until here 270 degrees, which means that there are only angles occurring here. And if you remember the names of it, it's Q1, Q2, Q3, Q4, so it's only here. But in addition to Q1, Q2, Q3, Q4, you must also know ASTC. Right, so what does that mean? It means that in quadrant 2 sine is positive, quadrant 3 tangent is positive, right? Okay, so now let's try and figure which quadrant angle A and angle B belongs to. Over here they tell you tangent A is positive 8 over 15. So do we care about the 8 over 15 for now? Not really. We only care about the fact that it is positive. So let's think about it. If you're an angle here and your tangent of A is positive, which quadrant can it be? Can it be in quadrant 2? No, because here says S, which means only sine of an angle in quadrant 2, obtuse angle, is positive. Everything else, cosine and tangent, will be negative. So this is out. So by elimination, we can only conclude tangent of an angle in quadrant 3 is positive. So this means that, so the working is like this, is positive, which implies A is in general in quadrant, what are the two quadrants for positive? Quadrant 1 or quadrant 3, right? But we know that A is in between, we know that the angle A is in between 90 degrees and 80 degrees, 90 degrees and 270 degrees, sorry, so that means A is in Q2 or Q3. Then if you want to satisfy both conditions, there's only one possibility. Overall, it means that A must be in quadrant 3. Okay, both conditions must be satisfied at the same time. Only quadrant 3 is the A can only be in quadrant 3. That is the only possibility. Then using the same argument, but this time for angle B, we realize that tangent of B equals negative 24 over 7. We don't really care about the value 24 over 7, we just care about the fact that it's negative. Negative means that it's in what quadrant? Let's see, so B is in quadrant what or quadrant what? Negative. Only A and T will have positive tangent value, so that means negative must be these two quadrants. Quadrant 2 or quadrant 4. Quadrant 2 or quadrant 4. Then what does it mean now? We must realize that, angle A, B, there are angles in between 90 degrees and 270 degrees, which means that A is in quadrant 2 or quadrant 3. So in order for us to satisfy this and this at the same time, it implies that we can only have angle B in, sorry, this should be B, B can only be in quadrant 2. Okay, that's good. So now that we know these facts, we can use this to do step 2, which is to find the relevant trigonometrical ratios. If you look at part 1, cosine A minus B, take note that it is serious mistake to say cosine A minus cosine B. It is not that simple. You need to use the addition formula or the compound angle formula. There's an A minus B going on inside. So for cosine A minus B, it's actually cos A cos B plus sine A sine B. Alright, so it means that we need to find the sines and cosines of the A's and the B's. So let's just work it out. How do we do that? Second step is to use the right angle triangle. Right angled triangles. Okay, so starting with tangent A equals to 8 over 15, it means we can just draw a right angled triangle like this. I know angle A is not a acute angle, but for practical purposes, you can just think of this as the reference angle. This diagram is good enough. We can use ASTC later. So here when we see tangent is 8 over 15, it means opposite over adjacent. So it's 8 here and 15 there. And if you do a bit of Pythagoras theorem, 8 square plus 15 square, and then you take a square root, you end up with a 17 over here. That's the hypotenuse. So we need sine A and cosine A, so let's figure that out. So what's sine A? Opposite over hypotenuse, right? So it's 8 over 17. But wait, angle A is in quadrant 3. And we know that in quadrant 3, only tangent is positive. So that means we should have our minus sign over here for sine A. For cosine A, adjacent over hypotenuse, so 15 over 17. But wait, cosine of angle A, where A is in quadrant 3, only tangent can be positive, so cosine of a quadrant 3 angle must be negative. So we put a minus sign over here. See, you don't have to make this diagram, you don't have to make this angle A really a quadrant 3 angle. You could possibly draw this diagram instead. This would be the real angle A in quadrant 3, but I seriously don't like that because it's very, very slow. And you label here 15, here with 8, and then here with 17. And yeah, don't need that. Nah, a bit confusing. I don't like that. So anyways, we got our correct values of sine A and cos A already. Not enough, we still need to find sine B and cos B. So let's proceed to do that. Tangent of B, the other ratio given to us, is negative 24 over 7. So we can again draw a right angled triangle. Label angle B there, right angle there. Tangent is opposite over adjacent, so it's opposite 24 over adjacent 7, right? Opposite over adjacent. Just ignore the minus sign. Just ignore the minus sign. Then again, Pythagoras theorem tells us the hypotenuse must be 7 square plus 24 square. If I am not mistaken, this should be 25, right? Then after that, we can proceed to find sine B and cosine B. So sine B is what? Opposite over hypotenuse. So then so opposite over hypotenuse, 24 over 25. But wait, angle B is in quadrant 2. Quadrant 2 sine can be positive. Okay, so we are safe. It's still positive. I'll just put a plus sign there for emphasis. You don't need to put that. Cosine B this time, adjacent over hypotenuse. So 7 over 25. Right? Angle B is here, adjacent is 7, hypotenuse is 25. Then after that, you think about it. Oh, angle B is in quadrant 2. Only sine is positive. Here we're looking at cosine, so it should be a negative. Alright, good. We have these two. Then finally, number 3, we can answer the question. Use the correct identity, I guess, to expand the question, the ratio that was given by the question. So in this case, for part 1, we need to find cosine A minus B. It's actually just cos A cos B plus sine A sine B. But what is cosine A? We have over here. What is cosine B? We have over here. What is sine A? We have it over here. What is sine B? We have it over here. And just substitute accordingly, one by one. Okay, done substituting. Just type in a calculator and get your answer. ... Whatever it is. Moving on. Part 2. Now we actually want secant A minus B. So what's secant A minus B? Is there a formula for secant? It don't have, then how? Then you don't have to worry. You just need to remember, whenever you see secant, just think of co, no co. So here, don't have a co. So it must be the reciprocal of the one that does have a co, which is cosine. But the angle, it's still A minus B with the brackets. That looks very familiar. Oh yeah, cosine A minus B. We already found the answer from part 1. So just take the reciprocal. 1 divided by dot dot dot. You can fill in the blank on your own. Then that's your answer. Okay, a bonus question. How about if we, since we're already here, why not just figure out what's tangent A plus B? What's tangent A plus B? Extension question. Well, tangent A plus B is just, if you use the formula, tan A plus tan B all over 1 minus tan A tan B. Right? And just substitute accordingly. In this case, we already have tan A and tan B, right? So we can actually, we don't even need to draw a triangle. We can just use the answer straight away. Substitute accordingly. I'll leave that to you to do on your own. You can fill in the blank. Sometimes they may even ask you, I don't know, secant of 2a. Oh no, how to deal with that? Well, you just have to realize that secant is what? Secant is really just 1 over co no co. Secant doesn't have a co, so this one must have a co, so it's cosine 2a. But we don't have an answer for cosine 2a. What do we do? So a few ways you can tackle this. Let me show you a very what do you call it? Standard way. Just use one of the formulas, right? So one such formula available to you is cosine square A minus sine square A. Right? Then you can just substitute accordingly, because what is cos square is just cosine A squared. So it's negative 15 over 17 bracket squared minus away sine A is what? Negative 8 over 17 bracket squared. And just key in the calculator lor. Done. Of course, you could use any other identities. The other two identities, I think it's 2 cos square A minus 1 and 1 minus 2 sine square A. Yeah, and then you just substitute accordingly. You will still get the same answer. But remember to take a reciprocal, because we're asking for secant. Yeah, and the rest are all quite similar. Just use an identity. Step 1 and step 2 should be quite familiar to you, hopefully. Then step 3 is the only one that's a bit different. Okay, use the correct identity. That's all.